Hey, good afternoon, everybody. Thank you very much for coming today. As Tom said, those of you who have not met me, I'm Matt Law. I work concurrently at a university, Barnsley University, in the geography department there, and for a commercial archaeological unit, Museum of London Archaeology, as they're called now, formerly MOAS, who I actually only joined in June. Previously, I worked for LP Archaeology, but they were acquired by London Archaeology. And I have been interested in snails and archaeology since I was an MSc student in 2005 at UCL, where I came into the sphere of influence of Ken Thomas, who I'm sure many people here will know, and who I'll certainly be bringing up a few times this afternoon. This year marks the 50th anniversary of the publication of what is essentially our Bible, book Land Snails in Archaeology, by John Evans, and Tom's brought a copy if anyone would like to have a look later. Well, I'll talk a bit more about the book in a few minutes, but it's very much a book that has shaped a discipline and continues to shape the discipline 50 years later, and is very much still a standard. Okay, so today I'm going to fairly briefly, a lot of this has been covered in quite a lot of depth in other places, including in land snails and archaeology, but I'm going to fairly briefly outline what archaeological land snail studies were like before John Evans began his PhD research, talk very briefly about John himself, and then about land snails and archaeology and what that brought to the discipline. The bulk of the talk, though, is going to be looking at how the discipline has moved on since 1972, the publication of Land Snails and Archaeology, and then close by just thinking about what some agenda points for the future of land snail studies and archaeology might be. So the idea that land snails from archaeological sites might have some relevance to archaeological interpretation has some antiquity. In 1869, General Pitt Rivers noticed large quantities of Pomantius elegans, then called Cyclostoma elegans, in ditches at Sisbury, Iron Age Hill Fort. But really the first at least systematic work was done by A.S. Kennard, Alfred Santa Kennard, who was an amateur worker, often working particularly in earlier years alongside B.B. Woodward. And he was able to, over a 50-year period, he was able to get hold of shells from a number of very key archaeological investigations, such as those carried out by Maud Cunningham in Wessex, famous sites like Woodhenge, and at Grimes Graves in Norfolk as well, where his interpretation was very important because there was some debate about the age of the features at the time, and he was able to demonstrate that it was post-glacial. He was very much driven by a sense that the occurrence of snails in samples was determined by climate and by humidity, rather than by factors like vegetation structure that archaeologists would tend to look a little more at nowadays. And initially his work was lists of presence of species, sometimes with relative abundance described as common or rare. But by the end of the time he was working, he had moved on to being quantitative, giving counts of shells. After his death, 1948, there was a bit of a lull in land snail studies in archaeology. But during this time, during the middle part of the 20th century, pollen studies had risen in ascendancy, and a lot of work was being done, particularly in the east of England, by people like Harry Godwin, interpreting environmental history using pollen records. And so, starting in the 1950s, Bruce Sparks at Cambridge began to work alongside people working at pollen records and look at snails, and he developed the first systematic approach to sampling and extracting shells from sediment, and also published the first snail diagram, a vertical sequence of samples that demonstrates the species within a vertical sequence of samples. in 1957. And then he and Michael Kearney, who we've just been hearing about, did a lot of work, particularly in quaternary investigations in southern and eastern England during the course of the 1960s and start of the 1970s. But writing in 1981, Myra Shackley, a geoarchaeologist in her textbook Environmental Archaeology, speaking about the time before Sparks and Kearney, said that too much emphasis in land snail analyses in archaeology was being placed on climate or on using snails as dating evidence for the deposit. As I said, nowadays we would tend to focus more on land, on vegetation structure, but I will want to come back on climate and dating evidence from snails in a positive light when we think about work that's been done since 1972. Another key development of the pre-war period, the 1920s and 1930s, was beginning to form a systematic understanding of the ecology of the species that we have in Britain. And it was work that had been done on this that enabled A.E. Boycott in 1934 to present a paper to the British Ecological Society about the habitats of land mollusca in Britain. And in this, he grouped species into ecological groupings. So we could talk about snails being snails of woodland, or snails being snails of wet places. This comes to be very key, and I'll come back to this in a moment, but we'll also touch on some of the shortcomings of this approach as well. So the scene is set. The late 1960s enter John Evans into the world of land snails and archaeology. He had been born at the start of the 1940s in St Albans, Hertfordshire. His father was a microbiologist, director of the London School of Hygiene and Tropical Medicine, and he studied zoology at Reading. And while he was at Reading, he met the curator of Reading Museum, J.J. Weimer, who was a very celebrated Paleolithic archaeologist, and made his acquaintance, and that ignited an interest in archaeology. So he came to the Institute of Archaeology here in London, nowadays part of UCL, to read for a PhD, which was initially supervised by Frederick Zoyner. Zoyner was a polymath. He was the world's first professor of environmental archaeology. He was famed especially for his studies on insects, on vertebrate zooarchaeology, and also in his role in introducing radiocarbon dating into archaeology. So a very key person to whose influence he fell into. Unfortunately, Zoyner died in 1963 at quite a young age, 58. And so John's study moved on to, Michael Kearney became involved in the supervision. Michael was working at Imperial College at the time, and John's study moved into looking at land snails. And he was able to work on a number of key excavations that were taking place, particularly in the chalk areas of South Central England, but also up in the Western Isles, where my PhD research based as well, through the course of his PhD. I'm sorry, his PhD was completed in 1967 under the title Stratification of Mollusca in Chalk Soils and their Relation to Archaeology. Much of his PhD research formed the basis of land snails and archaeology. There had been a couple of quite short texts existing to give a general sense of the potential of land snails and archaeology. So Bruce Sparks had contributed a chapter to a Science in Archaeology volume in the early 1960s. And Michael Kearney had written a key paper called Snails and Man in Britain that explored both an archaeological relationship of snails and people, but also modern relationships of snails and people and the introduction of new species. But John was able, through the work he'd done, to set out a very detailed exploration of chalk landscapes and also some blown sand landscapes, which had been the subject of a paper he had published the year before in 1971, and to establish the methods to essentially repeating the methods that Sparks had established, but to codify them into a manual for archaeologists to understand. And he presented an identification guide as well. And the identification guide is of a special value, I think, because it is one of the very few things we have that shows juveniles as well. So it's very simple line drawings, these traced from photographs. And actually, Paul Davies had the original tracings of these, which I've seen. But one thing we're very much lacking in land snail identification guides, I think, is a sense of what juveniles look like, especially when they are forms that are quite similar at the juvenile stage. So that's a very valuable thing that's in Land Snails and Archaeology book. He also introduced the ecology of the British species. He refined the ecological groupings for land snails based on the work of Boycott. And through looking at monuments, he changed our understanding of what the environment was like in British history. He's also been credited by Harry Kenwood, who's an archaeoentomologist, with being the first person to make the point that a death assemblage of invertebrates is not a reflection of a living community, and to explore the factors that shape what enters the fossil record. So that appears to have been a sort of tacit assumption, perhaps, before that point, but John was very clear about this. Following on from John's work in 1972, John obviously kept busy in the field of environmental archaeology. He was working at Cardiff University as the first lecturer in environmental archaeology outside of London. And in his own words, I looked at his university profile from 2001, shortly before his retirement. He retired in 2003. He described the heyday of his work as being the period 1985 to 1995. During that time, he had 10 PhD students through to completion. He had a number of grants, research grants. He was also very productive in a number of different ways. So in the 1990s, he started to make some forays into looking into ostracods and their role in archaeological interpretation, and published a small number of papers with a student, Hugh Griffiths. And then towards the end of the 1990s, and looking into the 2000s, he became very interested in more theoretical developments. And we'll come back to talk about some of these later as well. But from the 1970s, he began to be joined by a number of other workers as well. And adding these other workers to the field increased the density of data for some very key landscapes. So we can think particularly in terms of the Wessex Chalk again, the key prehistoric monuments, the more famous prehistoric monuments there, like Avebury and Stonehenge, and also Dorchester in Dorset. But also people started to look at the evidence beyond the monuments as well. So in off-site, what we call off-site investigations of the archaeological record. And this allowed what Mike Allen described in 1997 as being able to interpret the landscape mosaics within archaeological landscapes. So prior to this off-site work and prior to this increase in density of data, there was a lot of extrapolation from some key sites. But some of these landscapes began to be very well studied, and the wealth of knowledge generated over this time, from the 1970s through to the mid-1990s, has really allowed some very important observations to be made. So one of the first things that has been achieved in the wake of publication of Land Snails in Archaeology is that we have this higher resolution mapping of archaeological landscapes. So work carried out by a number of people actually has shown that woodland clearance has been a lot more complicated than was initially thought. One of the great developments of published in Land Snails and Archaeology was revealing that a number of the Neolithic long barrow monuments had been constructed in landscapes that had actually been cleared and were being used for agriculture some time before. So there was some time depth to the Neolithic use of those monument sites. However, looking at off-site evidence, and thinking perhaps especially of the work of Martin Bell here in the 1980s on the South Downs, actually revealed that rather than this clearance being an early Neolithic phenomenon, in fact, it was considerably more complex than that, and that clearance stretched from the Mesolithic, the previous period, through to later prehistory, and in some cases even to the medieval period. So we couldn't assume that just because a Neolithic monument was built on a site, it was necessarily the case that it had been built in an area that had been cleared sometime before then. Another thing that was very standard practice in the work of Sparks and of Kearney and of John Evans was to be looking at vertical sequences of samples from open sections, or perhaps from boreholes in some cases. But an innovation of archaeological sampling in the 1980s, 1970s, 1980s, was looking at lateral sampling as well. So where you have a monument that's been built, or you have a site that has succumbed to flooding or to blown sand encroaching on it, these will bury laterally extensive deposits, buried soil horizons. And by investigating changes in the species composition through that space, as well as up and down through time, gives us even higher resolution understanding of what is happening at a site. And a key example there is some of John Evans's work at the Eastern Down Long Barrow in Wiltshire, which is the selection of pie charts here. You probably can't read any of the text. There had been a vertical sequence through a ditch and pre-mound deposits on the site that suggested, as expected, that it was had been built on a cleared landscape. But actually looking at the lateral distribution of species across the monument, you can see the very dark colors here. These are the more shade-demanding species. And so it seems clear that there is some kind of ecological gradient underneath the monument being preserved at that time. Whether that is, when we say shade-demanding, and I'll come back to this again, we don't necessarily mean, as people may have thought for a while, snails of woodland, but we might mean a transition from shorter sward grassland in the north and east down to perhaps more rank vegetation in the south and west. In fact, independent evidence suggested that it probably was a woodland grassland boundary. But thinking about species like Coristium tridentatum there, which we might associate with being a snail of leaf litter in woodland, it is also very common in rank grassland where you have a dense grassy thatch. So we should perhaps not assume that a shade-demanding snail means woodland. Another very key development that perhaps is sort of, because it's something that archaeologists are so aware of, it's perhaps not something that we talk about very much, is that the context in which environmental archaeologists and land snail specialists are working has changed profoundly since 1972 and the 1980s, in particular with the introduction in 1990 of PPG 16, Planning Policy Guidance 16, Archaeology and Planning, and subsequently Planning Policy Statement 5 in the last decade. This established a kind of polluter pays principle of archaeology, where archaeological investigations become part of the planning process. And the result of that has been an increase in the number of people working in commercial archaeology, the number of commercially driven excavations, and in theory, at least, an increase in the amount of data that should be available to us. But it has come with some complicating factors. One of which is that there is a tendency for the samples that are received off of the site and looked at to be what are known in the language of environmental archaeologists as bulk samples. So big samples of up to 40 litres, perhaps a bit larger in some cases, which go through a flotation tank that separates a heavy residue from the material that floats. So far, so good. That sounds like there should be lots of good retrieval of shells. Many shells do float, several don't, however. I found in Hebridean work that I've done things like slug plates and some shells that open very widely quite quickly, so uncoil quite quickly, I suppose, like the Trina pellucida, tend not to float very well. Ken Thomas actually looked at this phenomenon with Lydia Zapata, an archaeobotanist, in relation to a site in the Basque Country, in a paper published in 2017, I think, and found that while there is definite underperformance of shells in flotation versus shells where the entire sediment is washed through sieves, it's actually very difficult on geometrical grounds, very difficult to predict which shells are going to perform badly or not. But a key thing to bear in mind, if you find yourself looking at archaeological land snail records, if they post date, particularly if they post date 1990, there's a very good chance that the shells being analysed are derived from plots, unless the snail specialist has gone on the site and taken samples or has been involved in designing the sampling strategy. So they may not be, the species compositions may not be as comparable to academically research-driven or older studies as we might think that they are. Interestingly, Marika van der Veen and some colleagues published a paper looking at archaeobotanical remains from during the course of the 20th century from classical sites from Romano-British sites in Britain, and found that in terms of the number of investigations and in terms of the quality of the data being produced, there had actually been a decline in the 1990s compared to the 1970s and 1980s. But that paper published in 2007, so we can assume being written in the mid-2000s, the data was not available for the 2000s. My suspicion is that as the statutory bodies that oversee the archaeological process have become more developed and put more energy into devising research strategies and guidance, my suspicion is that the quality has improved massively since those early days of commercial archaeology. Another feature of the work since the 1970s is that the analytical frameworks have been changing. In 1985, Ken Thomas published a very important paper that reviewed the theoretical basis for land snail analyses in archaeology. And he looked at a number of things, from the way that data are presented, in particular a reliance when looking at vertical sequences of samples, a reliance on percentage data. And he demonstrated how relatively minor fluctuations in some superabundant or highly abundant species can massively shape your interpretation if you're only looking at percentage data. So he advocated for absolute counts as well as percentage data. He looked at things like response rates of species to ecological change as well, and then started to think about how land snails become stratified within soil sequences and the degree to which there might be time averaging in that process. And he concluded, and I like this conclusion, but although it is somewhat unsatisfactory, he concluded that land snail analysis in archaeology has worked because the data generally make ecological sense, even if some of the assumptions of the empirical approach are rather shaky. One of the things he noted was that in comparison to, he used the example of archaeological insect analysis, archaeoentomology, he noted that there was a lack of use of numerical techniques of statistics and particularly diversity indices in land snail analyses, which is certainly true at the time. He does say in that paper that John Evans was working on something at the time, and another paper was published in the same volume that looks at diversity indices in archaeology. starting from the end of the 1980s, John, during his heyday, and his PhD students start to engage much more with statistical methods. And perhaps this is most fully developed in the work that John published in 1991 with Diane Williams on the snails from the root of the M3, which made good use of diversity indices, good use of ordination techniques as well. And it was carried on, particularly an ordination technique called detrended correspondence analysis that organizes the distribution of snails within samples along axes that account for the variation, although they obviously can't give any explanation. That was carried on by John's PhD student, Paul Davies, into the 1990s as well. Another innovation that John brought to land snail studies at the end of the 1980s and early 1990s is the adoption of the use of taxocenes. So this is a concept from ecology of species that interact with each other, that occupy similar ecological niches. They tend to be of similar size, similar life history. They will tend to have either direct interactions with one another or indirect, in that they might be the common choice of prey of another species. And looking at this became a way of looking at species associations without reference to predetermined ecological characteristics, such as these ecological groups that appeared in land snails and archaeology. The problem with using ecological groups, it became apparent through studies on modern faunas, some of them by John himself, such as John and Hilary Jones's study of rock rubble faunas, a lot of work by Rob Cameron as well, that the ecological groups are not absolute, especially at the shade-loving end of the spectrum. The species that we could think of as shade-loving actually can occur in, Robert Cameron showed they can occur in grassland with the complete absence of any grassland species if there's rank vegetation. And it became clear that because the ecological factors that influence the distribution of snails can vary at different times and different places, in ways that might be quite impossible to predict. Looking at species associations became a more powerful way of interpreting what we were seeing in land snail samples. So the taxocenes, John established taxocenes for dry ground fauna and also for wet ground situations, which were expanded a bit by Paul Davies, as a way of offering a new interpretive tool to understand factors like in the dry ground, for example, factors like stability, whether there might be ploughing or whether there might be grazing. Subsequently, however, the taxocene framework doesn't really seem to have been taken off. If we look at archaeological snail studies that have been carried out in the last 30 years since John's first publication on taxocenes, there are very few that make reference to taxocenes. One of the problems, which Tom identified in his PhD, is that actually they are very limited in their geographical scope because of the microvariation that there might be on an archaeological site as well. Their applicability are limited. So when we look at the ones that John erected, we need to remember that they work for central southern England, but we perhaps shouldn't expect them to work further afield. I have seen references to taxocenes in a little bit of work by Sarah Wiles in central southern England, and Mark Robinson made reference to them in a recent review of alluvial contexts in the Upper Thames as well. But it seems to have been something that hasn't taken off. Some other ideas that John was working with in this period in the 1990s similarly don't seem to have been taken very far, but I think are perhaps interesting and worthy of exploration. So on a site in Bavaria called Ed Golding, he looked at plotting the relationships of just two species against one another. And so he was able to demonstrate that some species have mutually exclusive in their occurrence in sample sequences, others are strongly negatively correlated. And that kind of species association also has some interest and brings some more detail to our understanding of what might be happening ecologically on the site if we understand enough about the ecology of that species. While the work on numerical analyses and taxocenes was being carried out, another important piece of work was being done, particularly through a PhD at the Institute of Archaeology by Stephen Carter, looking at the stratification and taphonomy, so the process through which shells enter the fossil record, or begin to enter the fossil record. Stephen looked at a site with a known environmental history and monitored the input of shells into the soil on an annual basis, and then extrapolated from that through the topsoil horizon to get an understanding of how long shells persist within a topsoil horizon. And as you perhaps might expect, more robust shells last a lot longer. The figure he came up with for Helocella etala was 335 years within that topsoil horizon, whereas for Belonia eccentrica, it was, I think, exact figure, but closer to 50 years. So an implication there, perhaps, is that if you have a buried soil and you're seeing lots of Helocella etala and some Belonia eccentrica, you should perhaps be mindful that there may well have been an awful lot more Belonia eccentrica at the time that soil was accumulating. One of the problems that was identified by Ken Thomas and by Bojan Lojek in 1990 as well is that over time, snail shell assemblage has become time averaged through the action of invertebrates like earthworms, through biological actions. And unpicking that is one of the challenges I think that we face. Again, some will come back to this point that Ken made, that actually land snail analysis works because the data make ecological sense. So if we've got lapses in response rates, where it takes several decades perhaps for an ecological change to show up in a living snail population, perhaps that goes some way towards smoothing the problem in the data of the time averaging. But people have been looking at how bad time averaging can be. The worst case scenario was a study by New and others, published in 2019 in Madeira, which found it was an alluvial deposit, so a hill wash deposit at the bottom of a cliff, which is perhaps the worst case scenario for time averaging. But using graphite targeted AMS dating, radiocarbon dating, they concluded that the time averaging was in the region of 10,000 years for that deposit, which gives us a little hope, frankly. However, other scenarios I think would not be quite so bad. Urani Yanis, who works in the United States and does lots of work in Madeira and the Canary Islands as well, came up with a 6-point scale of taphonomic impacts on shells that she scored shells against, and she then used statistics to assign them to taphofacies. So attempted to use commonalities in how worn the shell was to conclude which ones are likely to belong together as being in similar age. It will need a lot more work, I think, to be something that we can unpick. But for those who can't see my tricky set, I think that's where my thoughts as well. I have begun in my own work. I have begun to present a simple estimated ratio of shells that look very, very fresh to shells that are clearly much more worn, simply to flag the fact that there is time averaging at play. It's as simple as it is. Some further work of the 1980s and 1990s was beginning to think about the role that land snails could play in understanding site formation processes as well. So the work that John had done in land snails and archaeology and in his PhD was very much about reconstructing environmental histories on a fairly broad scale in terms of things like clearance. But people also began to unravel things like how snails might respond to the use of manure on fields, particularly again in the Western Isles where I've been working. Nigel Tew had been very vocal about that, and also thinking perhaps about how the quantity of snails within the deposit and the diversity of species within the deposit might tell us something about how long that sediment took to accumulate. Again, with bearing in mind the problem of later intrusions and time averaging. And finally, people began to think as well about biogeography and the use of snails for relative dating. I suppose actually this has quite some antiquity because it's something that Michael Kearney was writing about in the 1950s, but we'll be very familiar with the idea that Corneoaspersum, for example, is a Romano-British introduction. So therefore, if we find Corneoaspersum, presumably it is of a Romano-British or later date. That's obviously quite a circular argument. But the fact that we can now radiocarbon date shells using AMS dating, the fact that work is beginning to show that actually these dates are or can be quite reliable. This has not been conclusively established for, I don't believe it's been conclusively established for the British fauna, but there's been work in the United States that's been very promising about this. I know Tom has done some work on radiocarbon dating as well. And that's been very interesting. So I wanted to mention in particular the snail Coccosella acuta, which is a very ferociously common shell in sand dune environments, which we were aware from the work of John Evans and others in Cornwall and in the Western Isles in particular, was a later prehistoric introduction to Britain. So it seems to have arrived in Cornwall in the Bronze Age and be present in the Outer Hebrides by the earlier part of the Iron Age. Actually, Tom, working at Godrevy Towers in Cornwall, radiocarbon dating that shell, has brought that back in time, that initial arrival of Coccosella acuta, to the late Neolithic period, or to a period that spans the late Neolithic, early Bronze Age transition. Tom also notes that this suggests that there are connections with warmer parts of Europe at Godrevy Towers at this juncture, and that's a really important point. I think the movement of snails implies a movement of people, perhaps of animals or of plants. I think that's something that's we all recognize, but it's not talked about a lot, but it is an archaeologically very interesting thing that land snails can tell us, and developing some more research on those aspects of biogeography, I think, could be very useful. I'll come back to that in a moment as well. Some areas for growth that people have been working on since 1972, but perhaps not very much. First is looking at variation within species and measuring shells. This is something that Ken Thomas called for in a paper in 1978, and John Evans repeated the call for that. I'm aware of very few studies where there have been metrical analyses of individual species. Richard Preece has a very important study from Lashenwell in Dorset from a tufa deposit, presenting data on Pomatus elegans, which John referred to a few times and added to. I suppose there's a small corpus now of data about the size of Pomatus elegans. Traditionally, measurements would be taken using some key dimensions on shells. Ken Thomas presented these in, or an approach to these in his 1978 paper. Another approach that has emerged in other zoological and botanical fields is geometric morphometrics, which uses Cartesian coordinates placed on what are called landmarks or semi-landmarks around the edge of a shell. So I have here a tracing of the discus refundatus, and you can either specify that you want to have a certain number of landmarks and then overlay that with other discus refundatuses that are in the same accurately recorded in the same orientation. Or you can ask the computer to come up with semi-landmarks and just say you want to have 12, it decides where to put them, and it matches those. And by matching the occurrence of those between collections of shells from different sites, we may perhaps begin to unravel some of the drivers of shell metrics. So I've been looking at modern, it's a bit of an ongoing project, but I've been looking at modern discus refundatus to try and see if there's anything in the variation that I've seen in archaeological shells that could be predictably interpreted or reliably interpreted. At the moment, it's a bit of a mess. I've highlighted here a woodland area and a garden area, but then these belong with these, but they're clearly some other group, and I don't yet have an explanation for what that is. All I can say is more data are needed. So I had hoped to have finished this by now, but it's becoming a bit of an ongoing slug. Stable isotopes from land snails, likewise, are not something that has been explored in a huge amount of detail in a British context. So using the ratios of oxygen isotopes within a shell, we can begin to unpick temperature histories, and perhaps by using the final growth stage, we could perhaps begin to think even about seasonality. If perhaps it's a species that is of some kind of economic importance, perhaps a dietary species, that might be interesting. I have started some work with Kerry Davies of Bath Spa and Jennifer Jones at the University of Central Lancashire. We have a small amount of funding for a pilot study looking at lead isotopes from land snail shells to try and see if they work as an archive for different sources of pollution. The idea being that you can trace the sources of lead, because lead sources have unique isotope ratios. A potential other area that might be worthy of exploration is looking at nitrogen isotopes, and perhaps thinking about whether whether manure was being spread on land that using nitrogen isotopes, which is something that's already done with cereal grains by Amy Bogard at Oxford University. There has been some work on population genetics as well. In particular, a very interesting study by Grindon, who looked at Sapien nemoralis in Ireland and found, so comparing the genetics of living populations of Sapien nemoralis with those from elsewhere in Europe, and found that the origin of the Irish population seems to be in Spain, possibly in a Mesolithic date. Again, this is something looking at the kind of work that John's been doing with Coccicella aquita. It might be a very nice complement to that, to look at population genetics across Europe and see if we can find an origin for these late Neolithic Coccicellas. And finally, almost finally, another area for growth is looking at some kind of non-traditional contexts. So things like urban sites and houses. One of the problems there is that numbers are generally quite low. So we would want in the region of 150, 180 shells, the minimum for an ecological reconstruction. But actually, in some cases, low numbers of shells can be very meaningful, particularly if they are reflecting some kind of human behavior. So here's a little conceptual model that I came out with for how snails might enter houses. and what we could perhaps say, looking at house deposits. So perhaps some rupestral or geophobic species might be associated with walls, with standing buildings. We can have species introduced through thatch used in roofing or in flooring material, or if there's animal stabling. So in the Western Isles, for example, Clackalan, the Bronze Age roundhouses there, we have species associated with the lock margins beyond the houses. Nigel, you and I conclude that we introduced through roofing material. Marram grass, sometimes used as roofing material, could introduce Helicella itala, Helicella kita. If you have animals in a house as well, then perhaps some species that were associated with dung, like Oxyclamis alioris, maybe there. In more modern houses, we're fully aware. So Turton and others would have did write about snails in houses, and we think about, our cellar slugs, or why we call Oxyclamis salarius. We may have species that enter to hibernate as well, like the sapirs. And then strays, which are anyone's guess, really. There could be all kinds of reasons why those shells might be there. But I think that potentially there is some mileage in looking at shells from a variety of urban deposits and beginning to draw them together in some kind of synthesis, and seeing if there are any kind of recurring patterns. Because certainly, because most development takes place in urban context, we have a lot of data at this point. Although getting hold of some of that data is another problem. Okay, two more things I want to discuss, and then I am done. To come back to John Evans, I mentioned that he, in the 2000s, began to think about how people interact with the environment. On his web profile in 2001, his staff profile at Cardiff, he said specifically that this was in response to criticism that environmental archaeologists had received from theoreticians through the 1990s. And his thinking about this led to two very stimulating books, Land and Archaeology in 1999 and Environmental Archaeology in the Social Order in 2003. Snails form one of the things that John stated in the 2003 book was that the texture of the landscape, textures that we experience in the landscape, are an important part of our sense of belonging in that landscape, that they shape our perception of it, that we interact with those in a way that perhaps we don't give that much credit to. And so he started to think about the role that snails play in there. And we can certainly think in, again, to bring it back to the Western Isles, if you're walking across the dunes, you'll be very, very aware of the Cochlicella and the Helicella that are present there. You'll be a lot less aware of the Pygopygmaea that are present there. But certainly for some of these larger species, Helicellas, they are very visible. And John wondered if perhaps that people might have brought the snailiness, as he puts it, of a place into their understanding of that place. So place names like Snail Creek Hanging might be so-called not because they're edible species, but just because there are very textured surfaces where shells are very visible. And we see evidence of that occasionally in the archaeological record. So Martin's work at Bream Down, for example, there were one of the buildings had a cut that was filled with a deposit that was particularly rich in hydrovid mud snails, which certainly would have been a very striking feature. Presumably that fill had been transported from somewhere. So maybe, maybe there's a reason beyond the nature of the clay, but something about the snailiness that that made that attractive. John himself concluded, this is in, came out, a book that came out a couple of years after his death, the Scott under Witchwood, He himself concluded some of these ideas may seem a bit far-fetched, but he said that if environmental archaeology is to progress, then we need to be thinking along these lines. I think there are some very challenging ideas contained there, but certainly some things worth some consideration. So just to finish up, I just wanted to think about some agendas for the future. In 2008, a review of a book about snails and archaeology was published, which bemoaned the fact that the book essentially offered only more of the same. The idea there being that little had progressed since land snails and archaeology. It was a slightly unfair criticism, but certainly a lot of the work that is done is shaped by land snails and archaeology. And one thing that I think, I am certainly guilty of, and that I think is a problem for land snail studies in archaeology, is that at this point in the third decade of the 21st century, rather more of the work that is being done on land snails and archaeology is an incremental reporting on assemblages rather than methodological developments, rather than hypothesis testing. We are not in quite as healthy a shape as we were during John's heyday, 85 to 95. And I think that's a real shame. There are some problems, there are some structural problems though that are behind that, which is that there are very few people in a position to teach this. I know Mike's doing some teaching at Bournemouth.
Just generally not enough of us out there, full stop.
Well, yeah, not generally enough of that there, full stop. But I do, I think I'm among the younger people working in this field, and I'm in my 40s, so we need to attract more people, and there needs to be some thought given to where younger workers are coming from, how they're going to be trained, what their career structures will be. I mentioned briefly that we have lots and lots of data. This is true through the commercial archaeology process. Lots of data is being generated. Lots of it is incredibly hard to find. And when you can find it, it's not very accessible for things like meta-analysis because it's tables in PDFs. That's something that I think also, I think a lot of the data, as I said, in the context of urban deposits or houses, I think there's a lot of data that's ripe for synthesis. And we're lucky that we've had some people who have worked extensively in particular geographical areas, who do that synthesis work, but it's much harder if you're reaching across several different workers' work, if it's in the grey literature that's produced from archaeological excavations. And finally, I think we need to think about perhaps how snails can capture archaeologists' imaginations again, because Land Snails in Archaeology was a book that was on the shelves of lots of archaeologists, not just environmental archaeologists. When Ruth Tringham retired, she was a prehistorian who had gone out to Berkeley to work there. Her PhD student offered me her copy of Land Snails in Archaeology. Stupidly, I advised her to sell it instead because it's worth so much money. But yeah, it was a very, very widely read book, and it would be nice to think that we offer enough to archaeology that people will still want to widely read our work. Thank you very much. I will leave it there.
Thank you very much for that. I think that was a fabulous story of what follows on from what was pioneering work. And I know that Martin Bell has often told me he regards Land Snails in Archaeology as one of, if not the most important book on environmental archaeology of all types ever. And I think your very fine last statements really confirm that. So anyway, I'd like to throw it over to questions. I'm quite sure that there are people who want to ask questions. I hope so. So, anybody? Mike?
Thank you very much. Excellent discourse. And I think one of the things that I find frustrating about working in snails and archaeology is that John's book is still vital, and essentially some of the work I'm still doing could be written in 1973. But there isn't much, nothing much has happened methodologically, nothing much has happened scientifically. There are new elements which we can key into in terms of isotope and other things, but they're not going to be part of the development package. And the other thing that you said is that I have created a huge wealth of data which is sitting there, and we don't have enough time to actually burrow into it and do something. Now, I've made some global fantasy ideas of what I think all this means together, but it's all done through comparison and ideas and thoughts. But that set of data is just waiting for somebody to sit down and do something mathematical with it and actually see whether those ideas I've come up with are completely just mad and stupid, and what is really there. And what we need is more people doing snails and archaeology, but then also what we need is the people who are doing snails and archaeology to be more archaeologically relevant, so our paymasters realise its value.
Yeah, absolutely.
I think that I rather cruelly got criticised. No, I got fairly criticised by rather cruelly indicating some of the differences between these two fantastic books that appeared in the 1970s on snails and soils. And one of them was read by the archaeologists a lot more than the other. And that's because if you look at John's title, it said Land Snails in Archaeology. And the other one was an excellent book, which I still have on my shelf. It's called Soil Science and Archaeology. And they're what is the difference? And I think that we should be settling the former camp.
Yeah.
And therefore, the only way that snails and archaeology will expand in archaeology if we're talking their language.
Yeah, absolutely.
Jude.
Going back to the early days of Kennard, Woodward, and people like that, a lot of people there were a lot of general naturalists around, and although somebody might be a geologist, etc., they had a general background in natural history. They've been poking around in plants and animals and butterflies and insects and things. Natural history, and that's where I started. And natural history has rather fallen out of general practice. So people who come to academic studies don't come with an existing background of natural history studies. And then also snails in archaeology, and archaeology is a wonderful meeting of disciplines. And I was teaching environmental science in the early 1970s when it came to me really through working on archaeological digs, in the 1960s, dare I say, that you have a mixture of disciplines. You have people on the art side in archaeology, people on the science side, and the disciplines are mixed up together for the general interpretation. So I think we're losing a little bit of the background with the broad background which people started off with.
I think you're absolutely right. Yeah,
and also the key to the past is in the present. And Michael Curley, doing the non-marine atlas, he was constantly out in the field, and he had a good feel of the sort of places which Ricky and Clyde Tatum would live, the sort of places which Laura Sullivan would turn up, and that field experience built into his general synthesis of the interpretation of the snails in archaeology.
I think that's absolutely right, and that can be quite a hard thing. So think back again to the context that I find myself in of commercial archaeological work. Mike just said there's things that our paymasters aren't going to pay for, and that kind of depth of ecological understanding, the time it takes to build that up is something. Again, if we don't have well-established training pathways, it's difficult to see where that knowledge is going to come from beyond the somewhat limited scope of what people read. There's no substitute for the field experience as well.
You're also back to the value of societies such as this one, and also general natural history societies,
absolutely,
which are in the decline at the moment. And again, our numbers membership is down compared with, for example, the 70s when we had a membership of about 700, and a meeting like this would pack about 75 people into the room.
There's nobody in the universities now who can take our commercial data and do something fabulous with it. You know, there's no Evans, there's no Ken Thomas, there aren't loads of those people there to sit there and do something with that data and tell us where we're going wrong or where we need to look. But Jim, you're absolutely right. It's a shame that if you look at John's book and even the work we're doing now, isn't it bizarre that much of our data is based on papers written in 1934 and 1936? And when I wanted to try and do some more, to get some more ecological work, the only way to do it was get out and give us stuff.
Exactly.
And John did also do a good literature for, didn't he, for ecological papers?
He certainly did,
as well. I mean, some of my stuff is quoted in those. So he did a good literature search. So individual species, this is what's written on the species, and of course you pick out the gaps as well.
Can I just say,
Richard.
can I just say a few words? I mean, I was an undergraduate in Cardiff when Land, Snails and Archaeology was published. So I was lucky enough to be at the at the sharp end when it appeared. I mean, John told me that the figures that you showed, all those diagrams, were very much an 11th hour addition. They were not conceived as being part of the structure of the book until really at the end. And he thought, well, it might be a good idea to have some drawings of these things in. So that's quite an interesting addition, because you single that out as one of the key features of the book, or most useful features of the book, but it was very much an afterthought. Yes, so just a couple of other things. You mentioned Pomacius elegans and the fact that there was differences in size between the modern population and the fossil populations. Michael Kearney also found the same thing in his site in Kent, in the Devil's Kneading Trough. And we also had it at another site at Waterbury, one of my PhD sites. We actually had that in the paper, but we had to edit it out because it was too long. But so anyway, that story is repeated at a number of sites, quite interestingly. But there is another site that I worked on in the Isle of Wight, where I also measured not Pomacius, but Cernuella vigata in a much younger deposit, in something that was Bronze Age and probably much later, where the Cernuella shells were both much smaller and had very different banding patterns than the modern population living on the site. I have no explanation as to why that should be, but it was a very obvious fact. But that I did write that up. You can look that up. The other thing you didn't mention was the fact that quite a lot of work's been done on the sepia, the changing banding morphs of sepia through time. Arthur Kane did a lot of work on that. And there are big differences between what you find in archaeological sites and what lives on those sites today. And again, there's some quite interesting explanations for that. But anyway, I just thought I'd add that in.
Yeah, thank you.
Can I just say, on relevant to that, some of the work that Martin sites in Newbridge found Pupilla muscorum, which seemed to be much longer than other sites. And I know Richard's written on that one as well, mentioned it, I think. Anyway, Rosemary.
I was just going to mention that maybe some of these methodological questions might be answered with small projects, and that the Society does offer grants of up to £1,000 and would be willing to consider applications as such. The other thing I would mention is entirely a bit peripheral, is that John Evans' much desired and very difficult to obtain book on land snails in archaeology. I remember attempting to plough through it when I was about 13 in my local public library. When I wanted to go back to find it after university, it had disappeared along with all the other recent books the library possessed.
It's now selling for over £1,000.
Yeah, I got copies sold for £1,275 on the web about last week. I saw it up there, that price. I got using the buy at that. And 2 days later, it was gone.
Yeah.
I've got the first edition, which John sold to me for a special discount on the published price in 1972. when I was in
It
college.
was £7.50 when it was first
That's right,
published.
well,
There's a copy floating around Wessex, which has got a very rude comment in it at why the person who owned it had ever spent any money buying such rubbish. I'm John. So my copy is still around Wessex.
Do we have any more questions on that? Martin?
Well, thank you, Matt. For a really terrific summary of the last 50 years and for all the work that you've done to take it forward as well. One thing that occurs to me that makes John's 1972 book so important really is the multi-proxy approach that he took in that book. I mean, you mentioned Ostracods, but I think what is so exceptional in his treatment is the way he combines the land snail evidence with the investigation of short-term soil history.
Absolutely.
And it seems to me that that's something that we've lost a bit, actually, that soil dimension to the study of the routine study of land snail assemblages, and perhaps increasing the comparative approach of assemblages and their soil context and the evidence for soil history is something that would be another way of helping to refine interpretations
Absolutely.
in the future. But soil science and archaeology itself has, moved on a lot since then, hasn't it? Partly due to his pioneering research.
Definitely, yeah.
Right. And I think we should thank that and move all the way again to the next presentation.